Hello everyone, welcome back. In this video, I will be demonstrating problem number 13 of section 7.1. This is from the 9th edition textbook. Okay, evaluate the integral cosine inverse x dx. So in this case, as we don't have any elementary methods to solve this problem, we are going to use integration by parts. The rule is integral u dv is uv minus integral v du. This is integration by parts rule. So we have to identify what u is, what dv is in the integral. So let's call the given integral as I, which is cosine inverse x dx. So we have to identify what u is and what dv is. So let's take this cosine inverse x as u, and let's take this dx as dv. So we have taken u, which is equal to cosine inverse x. So we have to find out the differential du, which is derivative of cosine inverse x is negative 1 over 1 minus square root of 1 minus x square dx. And what is dv that we have chosen, which is dx. So v will be integral of dx, which is equal to x. So now we know u, we know v, which is equal to x. Then we know du, then we know dv. Okay. So let's use the formula here, integration by parts. So I'm going to substitute these values over here, uv minus integral v du. U is cosine inverse of x. V is x. We'll put them in parentheses and then we'll reorganize. Integral v, which is equal to x, and then du. Du is negative 1 over square root of 1 minus x square dx. Right? So this is du that I have substituted. So anytime you have cosine inverse of an argument, it's better to put that function after that outside of the argument. So we don't take as if it is an argument of cosine inverse. So we will just write like this to be on safe side. And then we have a minus sign over here, and there is another minus sign over here. So I'm going to call it a plus, and then integral x over square root of 1 minus x square dx. So the first part, we don't have to simplify any further. This one stays as is. The second part, we have to integrate as a separate integral. So it's x cosine inverse x. I'm going to call this second integral as I1. Then I'm going to evaluate this I1 separately, and then we will substitute in this step back. Okay, let me call that as A. So what is this I1 that we have to evaluate separately? It is integral x over square root of 1 minus x square dx. So if you know any elementary method, go for it. If you don't know, then we can apply. So far we have learned in this class, we have only covered substitution rule, which is ordinary u sub, and integration by parts. And you will be learning more and more techniques of integration. So among the two methods that we have learned so far, the best method in this integral to evaluate this integral is the u sub method. So it is u sub method is what we are going to use. So we have to choose u equal to, usually if you have a radical in the denominator, the expression inside the radical will be the best choice for u. You will take u equal to 1 minus x square. What is the next step? You have to do the differential du, which is negative 2x dx, correct? So I'm going to write this I1 entirely in terms of u. So the denominator is square root of u, no question about that. Numerator x dx should be written in terms of u, so which is or du. So if I divide both sides by negative 2 here, so I isolate x dx, which becomes du over negative 2. So which is du over negative 2. That is for the numerator x dx written in terms of u. So now let's do some cleanup. So I'm going to move the constant out of the integral. This is negative 1/2. Then integral du over square root of u, which can be written as, in order to integrate, we are going to use the power rule. We can write root of u as u to the 1/2 in the denominator, which is same as u to the negative 1/2 on the numerator. So if you apply the integration power rule, so it is negative 1/2 exponent plus 1. This is negative 1/2 plus 1, which is 1/2 over 1/2. So these two 1/2 get cancelled out. So it is negative u to the 1/2, or it is negative, if I put it back, the u in terms of u, in terms of x, which is negative square root of 1 minus x squared, which is I1. So evaluated this I1 separately, and then this goes back into the step. So I, which is the given integral in the problem, which is cosine inverse x of dx, because it's an it is an indefinite integral, because there is no limits, lower limit or upper limit. We have to remember to add the constant c at the end. So I have in this step A, x cosine inverse of x plus I1. So x cosine inverse x plus I1. What is that I1 that we have evaluated? This negative 1 minus negative square root of 1 minus x square plus a constant. So it is x times cosine inverse of x, negative square root of 1 minus x square plus a constant. This is the integral, indefinite integral, cosine inverse of x dx. Hope this video helps.